All right, thanks for joining me today for this cybersecurity discussion. My name is Dustin Mooney. I'm a cybersecurity professional. I run TechX Cyber as well as cyberfinders.com. TechX Cyber is a consulting firm. I help businesses understand what their cybersecurity challenges are, how to get on top of those, understand what their risks are, and how we tie cybersecurity back to the success of the business. That's really where my bread and butter is, and the gold is really understanding what these things mean to you. The other half of that is cyberfinders.com, which you can go check out. This is a web application that allows customers and businesses that are looking for cybersecurity services. It gives them the opportunity to raise their hand and say, hey, I need help with this particular project. Experts and cybersecurity consulting firms can come in and say, hey, I can do that for you. Let me tell you about myself. That customer gets to pick their favorites, they get to match, and then continue with a scoping call after that match has been completed. So CyberFinders really is a matching service, trying to really close that gap. We have a skills gap in cybersecurity, right? People are struggling to find help. And I think CyberFinders is a really good solution for that. So go check that out. If you're an expert or cybersecurity consulting firm, you can gain new clients on there. So go register and get yourself some work and help out some people that are in need. So today we're going to be talking about something a little bit more technical in cybersecurity, maybe like a side of cybersecurity, not cybersecurity concepts itself exactly. I am a digital forensic investigator. I've been investigating hacking, incidents, breaches, intellectual property theft, right? You name it. Anything that involves a computer that has some evidence on it. I've lived in that world for quite a while. So I wanted to talk today about digital evidence, what it is, how do we manage it, why is it important, what do we do that's wrong sometimes and mess up the evidence, right? So I want to talk about some of the mistakes and kind of how do we make sure we're capturing the right evidence. There is some evidence, if you're using the computer, there's some things that happen by default, but we can actually collect more. It's going to provide more value and insight if a breach does happen. So we want to talk a little bit about that. So my definition of digital evidence is just any sort of information that's stored on a digital media storage device. We're talking hard drives, cell phones, USB drives, computers, in the cloud, right? There's digital evidence. In your car, there's digital evidence. I don't know if I said cameras already, right? So anything that's storing information in the form of ones and zeros on a storage medium that can be analyzed, that can provide artifacts and clues about what was going on in that device. Now, something about digital evidence that I think people may not understand or that's really important to mention is digital evidence is created not because of the companies that made these devices wanted to give me as a forensic analyst something to analyze. Digital evidence is made most of the time because of the way that the either operating system needs to work or that hardware device needs to work. It's more of a side effect of something being configured to work a certain way. And so when we talk about digital evidence, one thing that I like to do when I speak to my customers and clients that really seems to resonate is I like to say, imagine a picture or a puzzle of a dog. So if you're putting a puzzle together and this is a golden retriever, digital evidence is a little bit like that, but now take away the ear, take away the tail, right? Maybe take one piece away from the body. And we may not have the whole puzzle, but we still know it's a dog, right? We can still kind of read between the lines and go, we think this is a dog. And so that's kind of what happens with digital evidence. We get these clues left behind, we get these pieces left behind, and my job as a forensic analyst is to collect those, bring them together, paint a picture of what I'm seeing and how I understand it and what it means to the events that we're looking for. So again, we may have some pretty good ideas of what we're getting ourselves into, but it won't be the whole picture. But it's enough. So that's kind of what digital evidence is. That's how I like to explain it to my clients. And so let's go into if we were going to collect some digital evidence, there's a couple things that really need to happen. There's some documentation that needs to happen, and I want to explain why this is really important. So when we create evidence, when we copy a hard drive, what we do is we call it a bitwise image. So we are copying byte 0 from the very beginning of the hard drive all the way to the last byte on that disk. So we're capturing every single byte in between. Now, that would be what we call a full disk image. There are other things called logical images where we may just capture what's on the operating system. And that will leave some data behind, but it's most of the time it's about 95% of what you need. You have options, and there's different scenarios of why you may collect something physically or why you may collect something logically. By default, physical is always the best. So if we can do that, we go physical. And so as you're doing this and you're creating these sets of digital evidence, oftentimes you're not just collecting one, you may be collecting multiple. And so organization becomes very important, and making sure you know where your digital evidence is stored and what device it was pulled from is a big piece of it. So that's one reason why we create some documents. The other reason why we create documents is to validate that none of the evidence has left the possession of the person that collected it, and if it has, that it's gone to the right people and legitimate people. So we use a document called a chain of custody form. As soon as I create an image of somebody's hard drive or computer, I create a chain of custody form. I write, what was the source of the information? What type of computer? What was the serial number? How big was the hard drive? And then the target media. Where did I save it? What's that serial number? How big is that hard drive? And then one big piece of this evidence creation part is what we call evidence preservation and validation. So when you collect evidence, it's very important to make sure that nothing has changed from the source evidence to the target evidence as you collect. So if anything has changed, you're going to have some problems. I'm going to talk about those in a second. But one way that we make sure nothing has changed is we perform hash calculations on the source, and we compute hash calculations on the target media as well. So what happens, I'll explain a hash. So I'm going to do this very simply. So hash value is a string of characters represented in a hex format that gets output after the data from any sort of digital media is run through a mathematical computation. The most traditional one that we use as forensics is called an MD5. Okay, so that string is like an identifier. That string is like a name. This hard drive that after I ran it through the MD5 gets this name. Okay, so how do we use this to verify? Well, what happens is if anything on that hard drive, if one bit on that hard drive is changed, if anything is altered, that 16-digit string is completely different from the one that was generated before it. So if we have this mismatch, we go, okay, something went wrong. Now, if it matches, so if the source is hashed and we get a 16-digit string, the target is hashed and we get the same string, we can verify that nothing has changed in the transfer process. So let me tell you why this is important. So let me tell you why chain of custody is important and why evidence preservation is important, and validation. So chain of custody, very important for scenarios where litigation is involved. As you're on the stand, as you're testifying, what the opposition and the opposing counsel is going to try to do as a forensic analyst is discredit you. They want to show that you've made mistakes, that you didn't do your due diligence, that you didn't follow industry best practices. So any sort of hole that they can poke in your story, even if you found the smoking gun, if you did not maintain chain of custody, that evidence could be dismissed. Because one thing they're looking for is, has this evidence been in your possession since the time that you took it? And if it's not, why did somebody else have it, and what did they do with it? Did they alter things? Did they change things? So that's half of the puzzle. Okay, so we want to make sure that we have had it, nobody else that's not supposed to have it has had it, and that we keep a running log of each time it gets transferred. So if I work in a company and I need to send it to my coworker, we're going to write that down and say, okay, this person is receiving it, I'm sending it. And again, it really just ultimately goes back to the preservation of that evidence to make sure that the integrity has not been changed or altered. Do you remember, if you go back to some of my other talks, we talk about CIA, confidentiality, integrity, availability. So integrity is, can I trust that this information is what I expect it to be? We can verify the integrity of evidence using an MD5 hash value. So again, if we see changes in those numbers, we can go, wait, this isn't exactly what I thought it was. And so that can be something, again, that the opposition can come and say, well, you're not working off the original evidence. Who knows what was changed on this drive? And it's a good point, by the way. So we need to make sure that we dot our I's and cross our T's. So digital evidence must have chain of custody, must have evidence preservation techniques used, and verification techniques used. So let's talk about collecting evidence, and what are some best practices. There's one particular thing that's coming to my head here, and I want to call this time after the event. So if there is an event that triggers a digital forensic investigation to happen, and we need to go in and make an assessment of what's going on, the time between when that event happened and when the evidence is captured is very critical, depending on some very specific circumstances. So as you interact with the computer, as you interact with a network, or you're saving things on a share, what happens is this evidence is being changed and altered, okay? And so one thing that we want to do is we want to preserve the state of that evidence as close to the event as possible. That way we minimize the noise that happened afterwards. A lot of times, and this is something I'm going to talk about in a second, but a lot of times the IT team will come in and start doing some preliminary analysis. Guess what? You're overriding evidence when that happens. You're creating noise for me to filter through to go, okay, is this an IT function or is this the hacker doing something? And by the way, the things that hackers do and the things that IT does, they look a lot the same, especially when you're doing an investigation. It can be really hard to differentiate. So the less amount of noise that we can create in between that time of the event and the time that we capture the evidence, the better. Let's see, I got a note here. If you're in a powered down state, that's a different story. So like, let's say you have a computer that's been compromised, you turn it off and you just leave it there and then you wait 3 months. That's okay. Not the best or not great, but at least that device is off and the new evidence is not riding over the old evidence. That's really the thing that we need to be concerned about. One big thing that we need, like for instance in forensics, one thing that we watch out for is plugging in a USB drive. Because that is, as soon as you plug it in, a lot of time like auto run will happen, or maybe it'll open up, what do you want to do with this drive? So there is a certain amount of evidence that can be stored. There are things that get rotated off, right? So we just don't want to be deleting anything that we may need. So it's best to just leave it alone. So let's talk about some mistakes. I'm talking about digital evidence, and I mentioned that IT likes to get involved. And I understand it. And one thing that we talked about was trust modeling. If you haven't watched the trust modeling video, go back and check that one out. There is a relationship between your company and either your internal IT or your managed service provider where you trust that they're going to be able to do a certain set of functions for you and behave in a certain way. Now, when we start getting into these more advanced technical topics like collecting digital evidence, this is where your IT team may struggle a little bit. Not because they're not capable and not smart, but it's probably just not something that they do very often. And it takes a very specific set of training to understand the right industry best practices to follow to make sure that we don't destroy evidence, that we collect best evidence, and that we do it as close to the event as possible. So there are some things that I see IT doing, which makes a lot of sense because these are just like very standard IT functions, and they think that this is their best practice is going to apply to the same thing of collecting evidence. But it's not. It's actually a little bit of a broken model. So IT likes to wipe and replace. Okay, we got an infection of malware. Let's wipe that device, put on a new operating system, restore our gold image, and then boom, we're good. That's not completely false. You might be okay after that, but we've just destroyed a treasure trove of information that I could have collected before we did that wipe and replace. So we don't want to wipe things out. Another big one is restoring things from a backup. So immediately IT wants to fix the problem, right, before we collect evidence. If we've got a virtual machine running and we can just restore it from a backup, then we're destroying evidence again. So these evidence tampering activities happen a lot. So what I tell IT is just stay away from it. If you can unplug it from the network or turn it off is kind of a second best option, not always the best because there's a lot of volatile data that sits as evidence, like memory, for example, that we could collect. So you really have to have the knowledge and the understanding of, I'm in this situation, what is my best path forward? That's where somebody like me comes in, because I know these things, I've studied them, I've done them before, I know what I need to do my job. It's just not a world that IT lives in. So you really kind of want to be a little bit cautious. If you're an IT provider, you're listening to this, contact a digital forensic expert. They're going to be able to guide you through the process. Now, when it comes to actually following the process, IT does great. They're very capable 99% of the time of helping collect images and things like that. The problem, or the area that we want to be careful of, is getting them involved primarily before they consult with anybody about what to do and what's the right course forward. So IT people out there, just be careful with what you're doing. And, those are some mistakes that I've seen. Those are some difficulties that I've experienced doing an assessment, going, is this the IT provider or is this the hacker doing these network scans, right? And so there can be a lot of confusion. So I want to move on a little bit and talk about what is the result of digital evidence? What are we looking for? Why is it important, right? And so what I'm trying to do is I'm trying to piece together what we call artifacts that get left behind by the operating system, by the networks, or looking through logs to get an understanding of what's going on. So when I have my digital evidence, one of the first things that I do is I try to narrow focus. Because if I look at a computer and, if I have a contract to work for a certain amount of hours, if there was no contract and they just said work as long as you can, I mean, you can look at a computer for weeks and day. I don't even know. You could probably just go forever. There's so much information, so many files, and you'll never go and sort through every single file. It'll just take way too long, and your brain will hurt, and you'll miss something, right? So what we want to do with digital evidence is we want to narrow our focus. One way that we do that is we create date and time ranges that we're most interested about. So we talk about time after the event. When that event happens, we have a starting point. If it's a month prior to when I get that evidence, okay, I know that I can create filters in my software to only show me things that are happening around that time frame. And then we can go back. Most of the time when a breach or incident has happened, finding out about it is something that's happened 6 months after the breach initially occurred. So we can narrow our focus, but we also need to pick and choose how far back we're going to go. So a lot of times breaches occur, the hacker sits in the system, and then we have this indication finally that something bad is happening. That indication is really probably either the middle or the end of an attack. It's never really the first thing that's happened. So we need to find out how far back we need to go. So understanding dates and times in forensics and interacting with digital evidence is very, very, very important. We spend a lot of time talking about time zones, understanding how to convert time, epoch time. It's just such an important part of being a digital forensic analyst, as well as being able to convert that, right? So maybe the computer's in UTC and I'm sitting at Mountain Standard Time, which is -6, -7. I need to convert those times for people and making sure that all of my timelines are matching up. Some evidence gets created in logs in UTC. Some will use the local time zone, right? So it's a little bit of an interesting thing that we have to find ourselves in to make sure that we understand when these events occurred. So I want to move on to what was the result, right? What are we trying to do? So what I'm trying to do is paint a picture of what this evidence is telling me. And I want to say what this available evidence is telling me. And again, we get this picture, we get these artifacts, we know times. At this time, this artifact exists, and it suggests that these events took place. That's kind of what you might get in a report. Now, one of the things that I see a lot in my investigations that we need to go to that are about incidents or hacking is clients need to know, did evidence get out? Or I'm sorry, did data get out? Was there any evidence to suggest that the hacker was trying to steal files, zip up emails, and get them off of the network or off of that computer onto a location that they control so that they can spread them from there? So does this evidence exist? Okay. And so this is probably I'm going to say one of the second most challenging things to solve in a digital forensic investigation, the first one being attribution. The next one is, did evidence leave the building? Now, it might not sound like that's that hard, but I'll tell you why. Evidence is only created in the places that you ask it to be created beyond what is set by the default operating systems. Okay, so what do I mean by that? So when you turn on Windows, there's a set of logging that happens locally on that device. It may log particular events and may log for particular amounts of times or up to certain amounts of storage space. So if we just use the default, we are going to get something, but it's not going to be a whole lot. There's probably more that we can get. So I guess what I'm trying to say here is we will only get the evidence that we decide to generate. And so sometimes I get clients and customers that ask me to say, well, in your report, can you say that no evidence left the building? And what I have to do is I have to say there is no evidence or artifacts to suggest the following. But the thing that I always go is, did you configure your operating system to collect that evidence that I need to make that conclusion? Is your firewall performing egress monitoring to log the communications that are happening in and out of your network? I need that information to know what files are going out. Did you configure that? So a lot of times that evidence isn't even there. So while we may do an investigation and, well, I don't see anything with this evidence, sometimes we're not generating the best evidence. So that takes me to my next point. If you are a business, if you are a company, you have to go in and take a look at where your evidence sources are being generated. I mentioned Windows. Yes, there is evidence collection on there, log collection. What about advanced audit logging, right? Have we turned that on? Have we increased the retention time of how many days of logs we're going to store? Usually we want to get about 90. Once we hit that 90, are we rolling those off to a central logging server and storing them for some predefined historical amount of time, like a couple years? Right? And so if we don't go through these exercises and we don't go and find out where evidence is being logged and increase these parameters, then we're missing so much. And it makes my life a lot harder to come to a definitive conclusion without that digital evidence. So if you're an IT person, if you're an MSP, one of the tasks that you should be doing is finding out where your logs are being made, increasing the size and the storage space of those logs, and turning on the more advanced features. If you're an Office, office.com, O365, go in there. There's all kinds of logging and retention policies that you can set to increase. Another big one that I see is email box logging, right? We want to increase the storage, increase the scope of the type of information that we're logging from those email boxes, especially in Outlook. Okay, so I think I want to wrap this one up here pretty soon, but I want to talk about what does evidence do in terms of cybersecurity? Like, where does it put us? So in cybersecurity, we really kind of want to be proactive. We want to get ahead of any problems. Now, logs are a little bit more reactive, right? We're kind of looking into the future. But if we don't spend the time to configure these logging sources and sending them to locations and storing them for a significant amount of time, we may not be able to come to conclusions about how a particular breach or incident happened. And if we can't do that, there's a greater potential, there's a higher risk, right? More likelihood that this could happen again because we haven't identified the problem of what happened and how to stop it in the future. So while it is something that's looking back in the past, it can be used to help prevent future attacks. So it kind of falls in this quasi-reactionary, quasi-preparedness section. So make sure that we're creating the right digital evidence that we need to do a proper investigation. I think that's everything. Drop a comment below if you want. Check out my website. Go to techxcyber.com. If you're a business and you're in need of some cybersecurity services for experts like me and other experts, you can go to CyberFinders, request some help, get some assistance from businesses. And that is everything. Thanks for listening, and I'll be back soon. Enjoy.